because of the ocean. That's what my teacher taught me, but I'm pretty sure that's not right.
I don't know.
Once upon a time, there was a man named OJ, and he was supposedly the creator of the earth according to the people of Atlantis. And people of Atlantis are all dead now, as their city was drowned by OJ. They're gone. So, after OJ died, after the people of Atlantis died, OJ wanted to make something in their remembrance and their legacy. And it is said that the people of Atlantis made the color blue. So OJ made the sky blue.
You need to talk about light and wavelengths first.
Say it again.
Light is said to have a dual nature. It can act as a particle or a wave. Waves are measured in wavelengths, which is said to be the distance from the top of a wave, a crest, to another top of a wave, or from the bottom of a wave, a trough, to another bottom of a wave. How often this cycle happens is called frequency. Different sized waves create different types of waves. The waves we can see are called visible light. This is a very small part of what is called the electromagnetic spectrum. White light from the sun actually emits every single color at once. Different frequencies cause different colors to appear. The light of objects you see is actually not what color the object is absorbing. Actually, it is the color of light that the object is omitting. It is reflecting off this color of light and absorbing all others. The color of light that is reflected into your eye is the color the object appears. The primary colors of light are red, blue, and green. These colors can be combined together to form secondary colors. Red and green are yellow, red and blue are magenta, and blue and green create cyan. These colors are called additive colors. Next, we need to talk about refraction, the bending of a light wave as it passes from one medium to another. This simple experiment displays refraction. A laser pointer is pointed at a basin of soapy water. As the light goes through the air towards the soapy water, the ray of light bends. Another property of light is diffraction, the bending of light as it passes around an object. For example, the sun and the moon create something called a corona when light bends around these orbs in the sky. It creates a ring of light around the object. Diffraction is also apparent when light is traveling through a small hole, such as through this small gap. The waves begin to come out in a circular pattern instead of straight. This is diffraction. These diffracted rays also are measured in wavelength and frequency. Frequency, how often the circular waves come out, and wavelength, the distance between each band in these waves. Now that we know a little bit about light, why does this mean that the sky appears blue? Why doesn't it appear red or green or any of the other colors of light? The short answer is, it's because of the way that light from the sun reacts with our atmosphere. Light from the sun hits the earth in all sorts of wavelengths. It takes about 8 minutes for light from the sun to travel all the way to our atmosphere. Once it hits the atmosphere, only UV, visible, and infrared light passes through because of the way that our molecules react with this light. Blue light is scattered by the molecules in all sorts of directions, while red light is allowed to pass through. The atmosphere scatters blue and violet light the most, while it scatters red, orange, and yellow light the least. This light passes directly through. As this diagram of the atmosphere shows, when white light enters the atmosphere, it diffracts through the space between the gas particles and scatters throughout the atmosphere. This is called Rayleigh scattering. Since more blue light is scattered and bends throughout the atmosphere, more blue light reaches your eyes. This is why the sky appears blue to us. So if blue and violet light are scattered the most, why do gorgeous sunsets like this one appear red, orange, and yellow to us? This has to do with the length of the atmosphere as the sun is setting at a certain point on the Earth. This is the distance light travels during midday. However, as the sun becomes more angled in the sky, it has to travel a further distance. Since the light now has to travel through more water vapor and more dirt, therefore, more blue and violet light is absorbed in the atmosphere and red, orange, and yellow light is allowed to pass through. Water vapor, in particular, has an absorption spectrum that absorbs more violet and blue light and emits more of that red, orange, and yellow light that we see in a sunset. What about that urban myth that says that the redder the sunset is, the more likely you'll have a sunny day tomorrow? Is that true? Yes, actually, it is true. This has to do with the fact that weather tends to travel from west to east. So when the sun sets in the west, there is high pressure, creating a lot of light scattering and a very rich sunset. Then, this high pressure moves during the night over to east where you are, and therefore this high-pressured weather creates a nice, warm, dry day. This is where the phrase, "red sky at night, sailor's delight," comes from. All in all, while it would be really cool if O.J. Simpson determined what color the sky was, the reason the sky appears blue, red, or even orange at different times in the day is due to the effect the atmosphere has on the light rays coming from the sun.